We're going to quickly look at this apparatus topic sheet. Alright, so let's get going with this. Right, that there is your beaker. That there is your glass rod. Right, you've got your funnel there. You've got your conical flask. You've got your evaporating dish or evaporating basin. Evaporating, I call it dish. Some people call it a basin. Right, okay. So we've got these words: beaker, funnel, Bunsen burner, glass rod, burette, thermometer, conical flask, and water. Okay. In step 1, the mixture of the salt and sand is placed in a that is this stuff here. It's placed in a beaker. Right. Containing, so that liquid there is water, and stirred with a glass rod. In step 2, okay. In step 2, the mixture from step 1 is poured through a funnel. You can call it a filter funnel. And normally you see another set of lines here, and that there is filter paper, but they've not shown it on here, which is fine. Right, through funnel into a conical flask. So this weird shaped bit of apparatus is a conical flask. In step 3, the liquid is transferred to a basin to allow to be removed the water. So what happens here is you put the Bunsen burner on, the heat will evaporate the water and you're left with salt. But anyway, let's keep moving on. Oh, okay. What should be placed in A before the mixture? Yeah, we've already said that. It's here. Filter paper in the filter funnel. Right, so that's why they didn't show it, so we put filter paper. Right, place crosses in 2 boxes that show the name of the 2 processes used in this separation. Right. Definitely not chromatography. Definitely not condensation. Definitely not distillation. Definitely not sublimation. So that just leaves evaporation and filtration. So filtration is occurring here through the filter paper, and evaporation is occurring here. Right, let's move on. Right. A student was asked to find the mass of salt dissolved in 100 centimeter cubed of seawater. So this is key because sometimes when they ask a question, they change this number. Right. She was given the following instructions: weigh an empty evaporating basin, transfer 50 centimeter cubed of seawater into the basin, heat the seawater in the basin until all the water has evaporated, allow the basin to cool and allow the basin and residue to cool, weigh the basin and residue of salt. During the experiment, the student used several pieces of apparatus. Some are shown in the table. Okay. Right, the measuring cylinder. We need to have a look up here. Right. And we need to get rid of no. Okay. Not there. What am I talking about? Sorry. It's I'm trying to link them. That is a separate question. Right. So the measuring cylinder was for that. So this is a measuring cylinder. Measuring cylinder. So they've not given you any hints this time. This is step B. So you fill this with the water up to there and you pour it in. Right, the tripod. This is an interesting one. Is like word. That's what I never talk about. There's the tripod. There you go. And then what you do, you put your Bunsen burner here. Oh, hello. They're playing up again. Yeah. Okay, doesn't matter. We'll have to live with that. Right, tripod. When you're heating it, that is a weighing scale or balance. A weighing scale, weighing machine, balance. And what was it used for? Yeah. There's one, and there's one. Steps A and E. Or A or E, they'll accept either. Okay. Let's move on. Right. They ask a lot about safety, so it's good to use your common sense. So right, there's heat involved. So what you could do is wear so you could wear gloves. Let's put it all in to stop stop being burnt because the basin will be hot when you try to handle it, or maybe hot. So there's a lot of heat. You might accidentally touch the tripod. Other ones that you could use is, I suppose, wear goggles. Why? Because the salt solution may start spitting out hot salt. Tie your hair back if you've got long hair, especially when you've got flames. right, to stop air catching fire. Okay, yep, that'll be enough. Right, the student obtained the following results: mass of basin with salt, empty mass. Now, how much mass of salt was there? So you had your basin, it weighs 78.6. If you put salt in it, it weighs 81.50. So the difference is, what is it? 2.9. Right. Now this is where you've got to be careful. Look. Okay, we'll live with that. Right. They've only used 50, but they want it in 100. So you just got to double your answer. So it'll be 2.9 times 2, which equals 5.8 grams. Right, let's move on. Right, Mr. Priestley produced oxygen by heating mercury oxide, mercury 2 oxide. Right, so we know he heated that, and we know he got oxygen. So now it's obvious then there's mercury left. Now we need to balance it. So we've got 2 oxygens on. You've got 2 oxygens here, 1 there. So if we put a 2 there, so I've got 2 mercuries, 1 mercury, 2 oxygens, 2 oxygens. So we just need to stick a 2 in front, not behind, because this is not a diatomic molecule. Right, the diatomic molecules that we look at is nitrogen, oxygen, hydrogen, and then your group 7. Fluorine, bromine. We just stick to these. Don't worry about anything else. What is the name given to this type of reaction? Right, I would be inclined to call it thermal decomposition, because you're using heat to break it down. So they'll accept that. No, it doesn't want to. All right, we'll stick with that. Right, but it's reduction and oxidation redox. Reduction and oxidation. Redox. Right, let's keep moving on. So here you've got the same idea. They want to produce oxygen, but this time they're going to use hydrogen peroxide. That's this thing here. H2O2. So remember, H2O is water. H2O2 is hydrogen peroxide. So they want to break it down, and they're using what's this thing? Manganese 4 oxide, and that'll break it down. Then the bubbles of oxygen will end up being gathered in a gas jar, with not downward delivery but upward delivery, because oxygen is less dense than, was it less dense than air? So you can collect it upwards. Although it'd be slightly soluble, it won't affect it too much. Give the name of the apparatus that contains the hydrogen peroxide. So this thing here. I call it a tap funnel. But it's also known as a dropping funnel or a separating funnel. Right, so I call it a tap funnel. Right, suggest how the first sample of gas may be collected, may be different. So collected may be different from the samples collected later. So now look, before you start, what have you got in here? Yeah, I didn't change colour. That is air. And air contains nitrogen, oxygen, argon, CO2 and other things. So what will happen is as oxygen's produced, some of the air will go down. So you'll have a mixture of air with oxygen. So that's how it's going to be different. Yeah, so it will contain air from the conical flask. Right, let's keep going. Right. I will just name these as they are then. Right. That is a beaker. Let me write it here actually. Beaker. This is a filter funnel, or I call it filter funnel. They'll accept just funnel. You have a conical flask, and that is a pipette. Right, normally on top of this you have a little, and you squeeze this, and then that draws up, and you can see there's a little marker there tell you. So for example, if you wanted 25, I don't know, centimeter cubed or 5 centimeter cubed or whatever it was, you'd get that. It'd have a little marker on it, a graduation mark, and you'd fill it to there. Right. Litmus paper.